Namaskar, welcome to Exercise Explained. So, in this video, we will be doing from question number 9 onwards of exercise 1A ICSE 10th force. The previous questions has been done in the previous video, the link for which will be there in the description below. Consider subscribing to the channel and do share it with your friends. So, let us start with it. A uniform meter rule balances uniformly on a knife edge placed at the 58 centimeter mark. So we have a knife edge which is kept here. So the meter rule balances on it. So when the meter rule balances on it, it is at 58 centimeters mark. When a weight of 20 GF is suspended from one end, draw the diagram of the arrangement. So here what we should understand is, since we have a meter scale that's going to be 100 centimeters, so the center comes at 50 centimeters, but it is given that it is balanced at 58 centimeters mark. So that means what? The weight on the left side is definitely more than the weight on the right side as of now. So the 20 GF weight, when it is suspended, it has to be suspended on the right side because right side is lighter than the left side. So we have to suspend it on the right side. So this is the trick about this question. You should always put the weight on the lighter side rather than on the heavy side, because heavy side will already be down. So in order to balance them, you have to put the weight on the right side. So draw a diagram of the arrangement. So here you can see I've drawn a diagram. So this entire distance is 58 centimeters. So this would be 100 minus 58. So that's going to be equal to 42 centimeters. 20 GF is hanging from the end B, as I've told you. And here what we should know is the weight of a scale or any object always acts in the center. Do remember that in moment of force problems, the weight of the scale always acts on the center of the scale. So here the center is marked as point O, and the distance from A to O would be 50 centimeters, and from O to B would be another 50 centimeters. Now you can see here I've marked the point distance X here. So this X is going to be the distance of the center from the fulcrum. So if we find the value of X, it's going to be 58 minus 50, because 58 is this entire length, minus AO, that is 50. So 58 minus 50 gives me 8 centimeters. Now in order to keep the rule balanced, clockwise moment should be equal to anti-clockwise moment. So taking the anti-clockwise moment about the fulcrum, it's going to be this weight, that is weight of the scale, into perpendicular distance, that happens to be X here. So W into X is nothing but 8 is equal to clockwise moment, that is 20 into 42. So I've written it as 20 into 42. 8 goes to the other side and we get 20 into 42 divided by 8. So if we cancel this, I have cancelled by 4. So 4 5s are 20 and 4 2s are 8. And here again I've cancelled by 2. So 2 into 21 times is 42. Now I multiply 21 and 5, I get it as 105 GF. That is 105 gram force. Getting into the next question, that is question number 10 of exercise 1A force ICSE 10th. The diagram below shows a uniform bar supported at its middle point O. So it is supported at the middle point O. You can see here we have 50 centimeters on the left and 50 centimeters on the right. A weight of 40 GF is placed at a distance 40 centimeter to the left of point O. So that means 40 centimeters from O, that is of left of point O, we have a 40 GF weight. So here this 40 GF acts on the left side. Now the question has asked, how can you balance the bar with a weight of 80 GF? So we have a weight of 80 GF and we need to put it on the scale such that the scale is balanced. Now going by the given conditions, we already have 40 GF on the left side. That means the left side is heavier than the right side. So definitely this 80 GF has to come on the right side. So let us consider it is placed somewhere here. You can see my mouse here. So this is where your 80 GF is going to be placed. So we can consider the moment about O of this force, that is the 40 GF force, is going to be 40, that is force, into perpendicular distance, that is again 40. So 40 into 40 is equal to, here what I get is 80, that is the force which we have to put on the right side, into distance we don't know. So distance I've taken it as x. So x is equal to 40 into 40 divided by 80. So we cancel the zeros here. 4 2s are 8 and then 2 into 20 times is 40. So we get it as 20 centimeter. So that means it should be placed at 20 centimeter to the right of O. That means here. You can see the mouse. So this is where it should be placed. So this was an easy question. Coming to the next question, that is question number 11. Figure shows a uniform meter rule placed on a fulcrum at its midpoint. So you can see here it is a meter rule, so it is placed at midpoint. So fulcrum is at the midpoint, that's at 50 centimeters mark, and I have marked all the centimeters here, and having a weight of 20 GF at the 90 centimeter mark. So we have 20 GF at the 90 centimeter mark, and the question has given one more thing, that is the 40 GF is at the 10 centimeter mark. So 40 GF is at the 10 centimeter mark and 20 GF is at the 90 centimeter mark. I have not written that in the question that 40 GF is at the 10 centimeter mark, but in the textbook if you see the question, it is clearly written that as 40 GF is there in the 10 centimeter mark. So we have two weights here, one 40 GF at 10 centimeter mark and 20 GF at 90 centimeter mark. So we need to find out, is the meter rule in equilibrium? So when will the meter rule be in equilibrium? When the moment or the clockwise moment will be equal to the anti-clockwise moment. So our anti-clockwise moment will be because of the 40 GF force, because the 40 is going to be pushing it in this direction and this is anti-clockwise, and clockwise moment will be because of the 20 GF force, so that's going to be pushing in this direction. So we'll be finding the individual moments by these two forces and we'll see if they are equal, it is in equilibrium. If they're not equal, it's not in equilibrium. So I find out the clockwise moment. So that is here 40 into 40. So that is 40 GF into 40 centimeters. So that gives me 1600 gram force centimeter. And we found another moment that is about this 20 GF. So 20 GF will be 20 into this distance, that is 40. So 20 into 40 gives me 800 gram force centimeter. So you can see here that the moments are not equal. So clockwise moment is not equal to anti-clockwise moment. So we can say that they are not in equilibrium. Therefore, it is not in equilibrium. And we can see that whichever side there is more amount of moment, it will be turning that side. So it will be turning this side. That is, it will be turning in the anti-clockwise direction. It will be turning in the anti-clockwise direction. So here the anti-clockwise moment is more than the clockwise moment. There is a small mistake here, that is I have written clockwise instead of anti-clockwise, and here I have written anti-clockwise instead of clockwise. So what we have to do now is, whichever side there is lesser amount of moment, we will have to add the additional weight to that side. Now we can see clearly that on this side, that is on right side of the fulcrum, there is lesser moment, that is 800 gf centimeter. So that means this will be on air and this will be on the ground. So what happens is, we will have to add the additional 40 gf on the right side. So what I do here is, the left side moment, that is the anti-clockwise moment, I write it as 40 gf into 40 centimeter, that is the force into perpendicular distance, is equal to clockwise moment. I write the moment for this, that is for this force, that is 20 gf into 40 centimeter, plus we have another force, that is 40 gf, into, we do not know where it is placed, but we know that it is placed on the right side. So I've taken it as x. So here 40 into 40 is 1600 and 20 into 40 is 800. So 800 goes to the other side, we get 1600 minus 800, and here 40 gf x remains, so I write it as 40x. So x will be equal to 1600 minus 800 divided by 40. So 1600 minus 800 gives me 800 divided by 40. 0 0 cancels, and then 4 into 20 times. So here we get it as 20 centimeter. So it should be placed at 70 centimeter mark. Now how do I write 70 centimeter? See, we already knew that it would be placed on the right side. Now this 20 centimeters means 20 centimeter right of O. Now O is at 50 centimeters. So 20 centimeters right of O means it will be at 70 centimeters. So this was an important question. So we have two weights which are kept on the right side, and there is only one weight on the left side. Now getting into the next question. So that is question number 12. When a boy weighing 20 kgf sits at one end of a 4-meter long seesaw, so there's a boy who sits at one end, so I considered it as the left end of a 4-meter seesaw. Seesaw will definitely be balanced at the center, so we consider it as 2 meters to the left and 2 meters to the right. So that makes it 4 meters. How can it be brought to the horizontal position? That means how can it be balanced? By a man weighing 40 kgf. So there's a man who weighs 40 kgf. He has to sit somewhere on the right side, because left side already the boy is sitting. So if the man sits on the left side, it will not go up. So the man has to sit somewhere on the right side. So we need to find where exactly the man has to sit. So here I have considered converting kgf to newtons, because kgf is not the SI unit and the distance is given in SI unit. So it's better we convert it off to newtons. So 1 kgf is 10 newtons. So 20 kgf will be 20 into 10. That's nothing but 200 newtons. And 40 kgf will be 40 into 10. That is nothing but 400 newtons. Now we would do anti-clockwise moment is equal to clockwise moment. So anti-clockwise moment will be this force, that is 200 newtons. So 200 into the distance, perpendicular distance, that is 2. So 200 into 2 is equal to, on the other side we have a person whose weight is 400 newton, but we don't know where he sits. So we'll take it as x. So x becomes 20 into 2 divided by 400, since 400 goes to the other side and becomes, it was multiplication, it becomes division. So 200 into 2 divided by 400. So that gives me 1 meter. So the person has to sit here. That is 1 meter to the right of the fulcrum or on the other side of the seesaw. So I have written the person should sit at 1 meter from the center on opposite side of the boy. So I hope the questions are clear. Since the video is becoming too long, I would be continuing from 13th question onwards in the next video, the link for which would be given in the description below. Do share the video with your friends and consider subscribing to the channel. Dhanyavad.